So you can start. We are live.
Okay, great. Thank you very much. My name is Hemachandra Bhat. I'm part of Wipro Limited. This is a multinational organization, and I'm heading the robotics practice as part of Wipro Limited as an organization. I'm basically talking about today IT OT integration and how it's going to help us to improve or basically make our shop floors better on a longer term. I think we've been talking about this in Industry 4.0 quite a bit. So I'll basically take up a case study and also introduce what we are trying to do from our side and what we believe that how it will look like going forward. This particular IT/OT integration, what is being talked about today. And in fact, as we speak, we are doing many projects for our customers in this space, and some of these examples I'm going to talk about are related to that. So quickly going into the first slide, what are the drivers for this integration, which is being talked about quite a bit, right? So I started my career as a manufacturing engineer in Wipro itself, and I can imagine like how the manufacturing floor was when I started off and how it is today, and it's transformed quite a bit, I mean more and more things are looked at today. So one of the few of the things which I'm going to talk about, and there may be many things, but I think these are four critical things which we believe that which are drivers for this integration. The first thing is the higher visibility into the shop floor, allowing greater flexibility to respond to changes, right? So this gives the management, be it on the shop floor or the senior management, to get a higher visibility and take decisions on the go, right? So this is very important from overall manufacturing process perspective. The second one is improved productivity due to optimization that we're going to do. I'm going to talk about a few of those things later on. So this is one of the very important aspects, because productivity and efficiency improvement is a very important aspect on the shop floor. So how can we deliver a higher productivity on the shop floor by optimizing the time, the delays, or whatever that happens on the shop floor today. Improved resilience, as we see today. I think with COVID-19, you're not able to travel quite a bit, and you're not even able to go to the shop floors in many places. So how can we improve resilience with this integration that's happening? So that's a third thing which is very relevant, and it's going to be important going forward as well. And of course, the analytics that we will be able to generate with this integration, with more and more data that's going to be available, which is going to play a significant role, be it predicting how much production I can make tomorrow or in the months or in the coming year, or it could be when I should do maintenance for my machines or robots or the conveyors that are there on the shop floor, right? So this is going to be very, very important for me so that I can reduce my downtime and effectively improve my delivery to my customers. So these are the quite drivers of what we see as driving the integration part of it. Going to the next, I think this you've already seen this, which is ISO standard, which is being talked about. There's IT on the top, there is OT on the down layers here. As you can see, they're not crossing each other, and they're just trying to meet each other. But I think that's what was the scenario. But I think it's changing quite a bit. As you can see, from level 0 to 4, whatever we see, 0 being equipment and top being the enterprise and enterprise applications. So it used to be that, yeah, IT won't meet OT and they're independent, and there's a lot of silos that this is creating between IT and OT. I think that's what is the integration is going to basically bring them together, and how we can deliver. I'm going to show a revised architecture, so to say, what we believe should be looking like, and And that's how we foresee as this going to be looking like in the coming months and years to come. So this is how we will foresee the IT will penetrate deep into the OT part of the story, and OT will, of course, has already reached there, and it is going to, as you can see, these are going to work in tango together, and make sure that they're very closely associated. In fact, they're going to interface with each other very closely, and see how we can actually connect to the upper layers in a seamless way, so that you will be able to deliver what is expected in this integration scenario. In fact, this scenario here has been shown for manufacturing. In fact, we have created something similar for a warehousing scenario as well. So the top being the SAP, and then you have MES, which is basically, at the MES level, I think we are looking at a plant orchestration. Of course, the historians, which you will foresee, which you'll see there. And in fact, the plant orchestration we are looking at differently, and I'll talk about it in the coming slides. So that's one of the things which is expected there. At the next level, we are looking at how can we orchestrate multiple processes, and how can we bring the concepts that were predominantly prevalent in IT down here, and see how we can get significant benefits, which you typically see in the typical IT, what people call about RPA, right, robotic process automation in the IT world. So how can we bring those into this world, and see how we can actually integrate this process level much better into the next layers, so that we can actually get an integrated benefit of IT and OT. So that's how we foresee here. I'm basically talking about predominantly a process integration here. I'm not talking about the design part of it, focusing predominantly on the process part of it here, on the shop floor predominantly. So next layer, of course, is the industrial robot controls, basically the controls of all these hardware elements that you see at the equipment level. And in fact, we are trying to see how we can actually build some, in fact, the IT layer, we're trying to bring down to this layer as well, to bring in some controls and bring in some reusability, which actually can help at the top layers to orchestrate the overall processes much better, in conjunction with the existing PLC and the controls that are existing at the PLC level today. Typically at the PLC level, you have most of the controls today, which are either the conveyors or you take carousels or anything you take at the lowest level, right? So drives that you drive, the motor drives and the VFCs, which you see in the equipment level. So we are trying to bring those elements here as well. In fact, this IT is penetrating deeper into the field as well on building some of those components. So this is how we see as IT and OT coming together in some of these layers. There's an overlap that's going to happen, and how they can connect together and build this overall stream into a overall integration theme, what we are looking at. In fact, I'll go a little deeper into the next slides on talking about what are those elements which we are talking about here on some of these elements which I just spoke about, right? So if you go to the next slide, in fact, I've taken a case study where we have actually implemented a similar scenario of integration and how we can actually, in fact, we are able to deliver certain benefits, which I just spoke about in the beginning. I've tried to provide some numbers later on. So this is typically a scenario where I have a stores, I have a similar different processes that are existing on the shop floor, and then some things get delivered and that get dispatched, right? So this is the overall process where we have autonomous mobile robot, which is also introduced as part of the overall process that helps in the material handling, goes to the stores, delivers it to the welding robot. Welding robot does its operation. The AMR goes there, takes the welded material, feeds it into the conveyor belt, and basically there are multiple operations that happen, and those operations are again orchestrated by the whole. I mean, this whole process is orchestrated where we have built a orchestration engine to do the process orchestration. I'll talk about that as well in the subsequent slides. So which actually helps to build the layers which can connect much seamlessly into the MES and the IT layers. So that's how we are looking at it, and that's how we have built this. This is an example I'm taking here, and if you go a little deeper into the example, so what I see here is basically some of the components which we have designed and integrated into the whole system here. As you can see, there's a hardware. There's a whole lot of hardware that is sitting here. The conveyors, fixtures, and many of these autonomous robots, collaborative robots, and as you can see here, the next level is the robot controls, and so we built some reusable controls here, which I'll talk about in the subsequent slides, which you can actually orchestrate at the next level, at the process level, process control layer, as you can see here. At the field layer, we built some components which will get used at, and at the process layer, we've again built some orchestration engines, which gets orchestrated at the plant layer. So, and then at the plant layer, we built connectors which connect to the enterprise layer, so that you can actually orchestrate the whole process from your enterprise layer. Basically, looks let's say a production planner comes in the morning and says, okay, I need to make 20 of these parts, or 30 of these parts. So the whole process should get orchestrated, and the person who has driven it should be able to see and get real-time visibility into what is happening across the shop floor. And also the person should be able to make decisions on the go, looking at what is happening on the shop floor. And so that, like I mentioned earlier, should be able to make decisions on how the production is going and what changes I need to make for my overall production plan, right? So beyond that, I mentioned about the resilience part of it. We've actually tried to build things like remote management components. So where I can actually manage my shop floor from my enterprise layer sitting at my home. So how can I do that? So basically, we built some layers with which you should be able to do that as well. So we believe that this is going to be the future, and this is how it will look like. And beyond that, I mean, if, for example, there is a change that is needed in the process, so how do you commission or how do you modify the process? So we built components where you can actually do a remote commissioning of robot. So because you see that the robot programming is or robot teaching is a difficult task on the shop floor when you're sitting outside the shop floor, right? So what we've done is we've actually digitized that. As you can see here, we have a digital engine where the whole process is digitized. I can actually create that offline. We can create a robot code in the form of an offline program, and I can use a remote commissioning and deploy that as well on the shop floor. So I can control the whole shop floor operation from this plant layer using UI that is available at the enterprise layer. So I can actually, as you can see, I spoke about the resilience where the current status of COVID-19, I should be able to manage my shop floor, right? So how can I do that? So the components like remote management, remote commissioning will really help you do that overall operation. Now we spoke about the process. If I need to build an engine for, let's say, for the overall process, how do I orchestrate this whole process? So what we're looking at is we built a configurable orchestrator. So what we can do is, in fact, I'll speak about a little bit more here, more in the subsequent slides. So what you can do is I can use process elements. There is in the process layer, I've built process elements for each of the processes, be it gluing process, or it could be machine tending, it could be welding, it could be multiple of those processes. So we have process elements that are built at the process layer. I can actually orchestrate them in a different ways, so that I can actually create a required process at my plant layer. So basically, so once that is created, I can actually run it from my layer that is from the enterprise layer. So as you can see, this configurable orchestrator will provide you and basically the efficiency which I spoke about in the first slide, if you remember. So this actually helps you to deliver that efficiency so that you can eliminate whatever issues you see in the shop floor, so that I can actually improve my productivity. I spoke about productivity there. I'll improve my efficiency and deliver higher productivity with the orchestrators that I can actually do at the plant layer. So as you can see, and I think the last thing which I spoke about in the first slide, as you remember, the analytics, right? So the analytics, as I have control of the whole process through my software engines, I get a lot of data at this layer, with which I can actually generate a lot of analytics at the enterprise layer. So I can generate analytics at the plant layer as well. So for example, I can at the process layer, I can improve my process efficiency using analytics. And if I go to the plant layer, I can actually improve my plant efficiency using the data that is generated at the process and field layers. And if I go to the next layer, enterprise layer, I can actually generate analytics for the whole plant, the complete plant operations, and actually I can generate analytics and say, hey, I mean, how is my plant running? What are the issues I'm foreseeing, and what are my bottlenecks? How can I improve my efficiency, right? So I can actually get those analytics at the enterprise layer. So as you can see, there are analytics built at every layer, so they can actually get efficiency improvements. I can build those efficiency improvements for my shop floor. So this is how we foresee, and actually this is enabled by AI layers. One is machine vision. You know that machine vision is going the AI way from the fully custom way. So as you can see, the deep learning and machine learning is playing a significant role, even in the vision analytics, or even in the going beyond in the predictive analytics. What we're talking about? How can I predict my how many parts I will make tomorrow, next month, 1 year from now, and how can I plan my production better? How can I predict my downtime of my hardware so that I can actually say, hey, I mean, I'm going to have a predictive maintenance in the next 1 month because I'm seeing a problem that's going to happen in the 1 month's time frame, but I can plan that and actually reduce my downtime significantly. So this is what we foresee that's happening in the IT/OT integration. As you can see, a lot of IT elements that are going to that are coming in and integrating very closely with the OT layer, and see how actually this is helping us to improve our overall efficiency on the manufacturing processes. So I spoke about the elements that we're talking about, how we can bring in some of the elements at the lower layers, which I spoke about, the field layer, at the process layer, and the plant layer. So we're actually designing some of these architectures. In fact, we've come out with this architecture. We, in fact, deployed this in this project, which I just spoke about. So we see that these are the elements which we are designing. In fact, this is one of the architectures which we've actually deployed for three or four projects, and we've been able to derive significant efficiency improvements with this methodology. How we can modularize each of these elements, starting from action, which is at the field layer. Action is one where I'd say that I open the gripper or close the gripper. So basically, that's basically an action that is controlling your hardware or equipment that is there on the shop floor, right? So going to the next layer, that is the process layer, what we call it as a task, and basically pick and place, right, is a process. So how can I pick an input part and place it there, right? So that's the next process I'm talking about, a pick and place, or it could be welding, or it could be anything of that kind, right? So these are the processes which are talking about, so which we are basically creating process objects in the process. Let's say classes is not objects, let's call it that way. Process classes in the terms of object-oriented programming, which is a pretty prevalent in the IT world. So we're bringing those concepts here and seeing how we can actually create classes of processes and basically use those elements to create real-time objects which are basically configurable in that sense at the shop floor. So going to the next level, the job and the application which you're talking about here, they go at the plant level, and how can I basically use these processes and basically build those jobs which are set of processes, right? So I need to make this job done today, then need to do, what are the set of processes I need to run. I can actually, we have actually built those orchestrators, so with which I can actually build this whole element of what I need to orchestrate for my particular job that needs to be done, or application that needs to be done today or tomorrow. Once I have put this together, I can keep this running continuously as and when I need it, right? So that's the beauty of it. I just orchestrate it once and put that together, and then just keep it running continuously, so that I will get the benefit of repeatability and basically I spoke about earlier, consistency and also the efficiency improvement, the productivity improvement I can get significantly over there. But and also what the advantage of this is we are building a consistent interface, so that I will get a consistent data for the next layers, so that I can build the predictive or prescriptive analytics, which I spoke about just earlier in my slides. Because of the consistency of this data interface layers across the processes, I'll be able to actually run this analytics much easier. So this is how an application object will look like. You have a lowest element of an action, then it gets wrapped into a task, task gets wrapped into a job, then jobs gets wrapped into an application. So this is a typical, if you're familiar with an object-oriented methodology, this is how your overall classes will look like, and the objects in basically when you instantiate those classes. So basically, this is what we have brought into the methodology of how to orchestrate this whole process. In fact, we are in this slide, I'm going to talk about off-the-shelf orchestration tools, which we have actually used here to build this orchestration. I spoke about the objects or the classes here. These classes are put in this form by the off-the-shelf orchestrators. I'm showing an example here called Camunda, an orchestration engine that's available off the shelf. You can actually use it. In fact, we are using Camunda and Adhesive as the orchestration tools, with which I can actually do a drag and drop through a UI. I just drag these processes and drop them here, and actually I can just put these together in the form of a process, so that it's so much easier. So at this level, this is actually at the plant level. For the plant level person, they don't need to know anything about the underlying processes. How do they run and what do they do? They just have to drag and drop them into the sequence of operations. A process is a sequence of operation, as you know. So I'll just drag them and drop them here and tell, like, okay, if there's a true or a false, or how much I have to wait. For example, I can build waits for so long, or I can say, if take a decision here, and if it's true, go here. If it's a false, go here. Actually, I can build a process through just with a drag and drop of process classes, what we call. Each of them is a class here for me. I just instantiate them here into an object, and this becomes my process, which I can run repeatedly after that. Once I build that and I save it, I'll just keep running it continuously on my shop floor. So you can see that, I mean, it becomes so easy for me at the plant level. I just it becomes a drag and drop, like you do your other software kind of elements, which you see, and the consistency and the interface is consistent, so I get exactly the same data and exactly the same output that is expected, so that I can integrate them much easier. So actually, with this, we've been able to actually deliver quite a bit of benefits to our customers in this example which I took, an implementation for a product which we did, we're able to deliver reduction in labor cost significantly at the tune of 80%. Reduction, in fact, idle time we're able to reduce significantly. So we're able to improve the productivity for the customer just by reducing the production idle time. And the requirement of skilled labor we're able to reduce significantly for our customer. And as you can see, there's only requirement of a 20% labor. So they're actually running at 20 people, and we're able to reduce it to 20% of that number. So they're able to get that benefit, and the skilled labor required was significantly reduced. And they were able to manage the shop floor from anywhere, right? So because we actually built this remote management tool, which we spoke about earlier, which I spoke about earlier. So with that, they were able to manage this from anywhere, right? So, and they were able to, in fact, there were a couple of cases where there were modifications required. So which was possible through a remote orchestration tool or remote commissioning tool with which where they were able to deploy the changes. I mean, I'm talking about a brownfield changes here. So they're able to do that as well. So this is, and also because of the consistency of operations, we're able to deliver a significant quality improvement for the customer. So that's what I want to say here. And in fact, we went through significant amount of challenges here. As you can see, balancing between security and efficiency. Security was an important factor, because how do you make sure the control is available securely, and we are able to build some controls through our orchestration engines and controls through the softwares. We're able to provide that to them, and we're able to balance efficiency and controls. There is significant amount of variability which we're able to handle here. There are different kinds of robots. There are collaborative robots, there is a mobile robot and a mobile manipulator, by the way, and which is coming from a different vendor. There's a robot, industrial robot coming from a different vendor. So we're able to handle all these variability very seamlessly. And there were significant amount of legacy systems we were able to basically integrate here, and we're able to successfully implement it. Digital model availability was an issue. We had to build a lot of models. And of course, the next one is how do we verify software orchestration with this hardware world? This is still a challenge. I think we are trying to overcome this. We are trying to build some tools here. And of course, the availability of right data was an issue. So we try to get consistency of data. We're able to overcome that as well. So I think this is another, basically on warehousing also, we've built a similar architecture, and we actually built a similar use case there, and actually deploying that as we speak for a warehouse. And in fact, this is going to be up and running with the SAP integration as well. Probably in the next 4 to 5 months, we should see is this up and running at the customer location. And I'm sure the customers will see huge benefits out of that. So coming to the conclusion, I just have 1 minute to go. And more customers are looking for automation solutions which integrate OT and IT. We see that this is going to be the future. And most of the hardware vendors are providing interfaces like OPC UA and similar ones that help standardization. I think many of the providers are doing that. In fact, customers are choosing hardware vendors and in fact robot vendors. We are in discussions with a couple of customers, and they were talking about who has digital capabilities. I want to choose that customer or choose that vendor. I think this is happening. This is becoming prevalent more and more. And of course, robot OEMs are investing, as we see, because of this. Robot OEMs are investing in developing platforms which are right now proprietary. We believe that these are going to be standardized in the months to or years to come, and we'll see a lot of standardization that's going to happen. So, and the AI and analytics is transforming the OT world, as we see, and it's going to be more and more prevalent in the manufacturing world, and you will see more of that. And I think that's how I conclude myself and say that IT and OT integration is real, and it's happening. And of course, it may not be prevalent today, but it's going to be prevalent in the months and years to come, and you will see many implementations in the months and years to come. Thank you very much. Thank you very much listening to me patiently, and appreciate your time, and hope to see you soon. Thank you very much. Mr. Nicholas, I'm done with my time as well as my
Here I am. I'm just. I